You can find information about the quadratic function f of x equals ax² plus bx plus c from the coefficients a and b, and from the constant term c. Take note, key concept, quadratic function in standard form. Take note of the information here, but we'll see it broken down in greater detail in the next few slides. First, the graph of f of x equals ax² plus bx plus c, where a is not equal to 0, is a parabola. If a equals 0, the function is a linear function. Note f of x equals 0 times x² plus bx plus c simplifies to just bx plus c, a linear function. If a is greater than 0, the parabola opens upward. Note the graph below. Notice that the y-coordinate of every point on the graph other than the vertex is greater than the y-coordinate of the vertex, meaning the parabola opens upward and the vertex is a minimum. If a is less than 0, the parabola opens downward. So notice the y-coordinate of every point on the graph other than the vertex is less than the y-coordinate of the vertex. And the parabola opens downward, and the vertex is a maximum. The axis of symmetry is the line x equals negative b over 2a. Note these graphs. In both cases, the vertical line x equals negative b over 2a forms the axis of symmetry. The x-coordinate of the vertex is negative b over 2a. The y-coordinate of the vertex is the y-value of the function for x equals negative b over 2a, or y equals f of negative b over 2a. Noted here in the graphs below. Recall that the axis of symmetry always passes through the vertex of the parabola. Finally, the y-intercept is the point 0, c. Problem 2. Graphing a function of the form y equals ax² plus bx plus c. What is the graph of y equals x² plus 2x plus 3? Well, step 1. Identify a, b, and c. For us, a will equal 1, the coefficient of the quadratic term x², b will equal 2, the coefficient of the linear term, 2x, and c will equal 3, the constant. Step 2. The axis of symmetry is x equals negative b over 2a. So substituting our values from step 1, x equals negative 2 over 2 times 1, and that's the same as negative 1. We can lightly sketch the line x equals negative 1 to represent our axis of symmetry. Step 3, the x-coordinate of the vertex is also negative b over 2a, or negative 1. So we can find the y-coordinate of the vertex by substituting the x-coordinate, negative 1, into our function. So the y-coordinate is y equals negative 1 squared plus 2 times negative 1 plus 3, and that's 2. So we can plot the vertex at the ordered pair negative 1, 2. Step 4, since c equals 3, our constant from the function, the y-intercept is the point 0, 3. The reflection of 0, 3 across our axis of symmetry, x equals negative 1, is the point negative 2, 3. Plot both points. Step 5, a is greater than 0, which confirms that the graph opens upward. Draw a smooth curve through the points you found in steps 3 and 4. Your turn. What is the graph of y equals negative 2x² plus 2x minus 5?